In this first fire demonstration, we have potassium chlorate, which is a strong oxidizer. We're melting it with a Fisher burner, and then we are going to add a sample of organic substance, in this case, a gummy bear. So we get a violent reaction when we mix the two, and this is why you should never eat in lab. You can never be sure what kind of reaction you might set off. In this reaction, we're taking a piece of regular cotton, and we're going to show you how it burns. So it's similar to a marshmallow. You get this black char on the outside of the cotton. Not all of the cotton burns, so you're left with carbon, which is ash. We can get a complete combustion if we change the chemical makeup. So in this next sample, I have mixed sulfuric acid and nitric acid with cotton, and that makes a substance called gun cotton. So it puts nitro groups on the cotton, which makes it burn completely. And this is similar to TNT. So those of you who play Minecraft know that it's a very explosive substance that completely combusts, leaving no char. And here it is in slow motion. You can see that fast fireball, and there's no char byproduct. You'll see this next reaction in the summertime. So think about where you might see these in the nighttime sky. We saw the luminol reaction with lightning bugs before, and this is another type of reaction that will produce different colors. So we have crystallizing dishes here. We're going to be adding a fuel substance to each of these, something that will burn. In the first dish, we have methyl alcohol, and that burns with a characteristic blue color. The next dish, you can see it there in the light, is yellow color. That is from ethanol, which is drinking alcohol. And the rest of the crystallizing dishes contain an ionic salt with methanol. So the methyl itself will burn, but it will dissolve some of the ionic salt and allow us to see the color of the flame produced. So different metal cations will produce different colors. The first one there is strontium salt. It has a very lovely red color to it. The next one is a copper salt, which has a blue-green color. The next one over is an orange color from the sodium ion. And this is the reason why wood fires have a yellow-orange color. And wood has a lot of sodium inside of it. The next one over is tough to see. It is a purplish color. So it has sort of an opaque quality to it. It is from a potassium salt. So potassium salts will burn with a purple color. And the last one is something you can actually do at home. This is boric acid. So traditional soap is called borax or washing soap. And this has a green colored flame. So this is not something that you want to do without adult supervision, but you could place this into a pumpkin, use a little bit of borax and some flammable substance, such as drinking alcohol, and you can get a nice green flame for October. So all of these can be found in fireworks. That's what gives them their characteristic color. If we want to extinguish the flames, what we're going to do is cut off the oxygen supply. So we have this flat piece of fireproof material. If we clamp it on top of the crystallizing dishes, we are going to extinguish the flames by removing the oxygen source. So we know that oxygen supports combustion from the elephant toothpaste lab. This next experiment is methane bubbles. So we're using methane gas, which is very flammable. That's natural gas. And we bubble it through a soap solution so that we end up with bubbles of methane. The reason why you can do this on your hands is because the methane gas is lighter than air, so the fire will burn up. So as long as there are no bubbles under your hand, you can put it on top and the fire will go up.